Assalamu alaikum. We are going to start a problem today. We are going to solve a problem with two-bit array um, for CS242. We have already solved some problems related with array. Today we'll solve this problem. This is basically problem like number 8. Problem number 1. We have to write a program in assembly language using MIPS instruction set that reads 16 integer number from the user. So 16 integer number from the user and store them into an array variable numbers. Array variable numbers. So the name of the array variable is numbers. Now determine and print the total number of odd and even numbers in the array variable numbers. So what you have to do, basically you have to read 16 integer number from the user, and all these 16 integer numbers should be stored in an array variable whose name is numbers, which is stored in 16 integer number. Now after storing this 16 integer number, now you have to check out that you have to determine how many numbers out of the 16, how many are even numbers and how many are odd numbers. So this is the problem. We are going to start the problem in MIPS. So the basic idea, again, I'm repeating, this is a array-related problem. You have to read 16 integer number from the user and you have to store them in an array. We cannot store them in 16 different registers. So we have to store them in an array, and you know that array is in the memory location. So we have to store them in memory. And then after storing them, we can calculate, or we can determine how many numbers of these 16 integers are odd and how many are even. Accordingly, we have to print this message: total odd numbers in the array and total even numbers in the array. So you can see that we have one input message and two output message. So we'll start here. First thing is new. So I'm declaring a data segment. So in the data segment, we are going to declare input message. So definitely this is a ASCII Z, and the input message is enter 16 integer number. So that's our input message. Yes, enter 16 integer number. And we have output message. There are two output message. Output message 1, which is also ASCII Z, and that one is basically how many odd numbers in the array. In this particular example, actually, you can see that total number of is 8 and total number of even is also 8, but it depends on the input data. If user enters different set of input data, you can have a different number of odd and different number of even. Anyway, so we are going to write the output message 1, total numbers or total odd numbers in the array equal this, and then output message 2. Just need to check whether we do it on. Yes, we do it on. Then dot ASCII Z, total even numbers are in the array. So that's our all input variables, but the most important thing is that we need to declare our array variable. And as I told in the class, you must declare your array variable before you declare all your input or output messages. So before you declare all your other variables, you must declare your array variable. As I told you in the problem, your array variable name should be numbers, and it should be word type variable, because the integer type data we are going to store. But we we cannot declare it at word, because if we declare it at word, then we have to assign all or initialize all our array content. All the elements of the array need to be specified at the beginning. But since we don't know the content or elements of the array, we are going to read each element of the array from the user. So we are going to declare it as a space. And since we need to read total 16 integer number, you can see that we have to read total 16 integer number. So enter 16 integer number. So 16 multiplied by 4, we need to allocate 64 bytes. So this is your array variable, and this is your input message, output message 1, output message 2, total odd numbers, total even numbers in the array. Now, we are now going to start the text part of it. So while we are going to solve the problem, the first thing first, very easy one, that you need to print the message, input message 1. And as you know that for printing input message 1, the interrupt number is number 4. So we need to put the interrupt number 4 in v0. So v0 is interrupt number 4. And then we have to put the starting address of this input message in the A0 register, and you have to use load address instruction. Load address basically gives you the starting address of of a string or of an array. So load address $A0 comma is input message, input message, and syscall. So this part of the code is basically responsible of printing an message input message will be printed. These 3 lines of code is basically responsible. This interrupt number 4 basically responsible for printing any string, So here we are using interrupt number 4, and then we have a input message, starting address of the input message. We put in A0 register and then syscall. So after doing that, we are going to read number from the user. We are going to read 16 integer number, so we cannot read 16 integer number using separate interrupt number 16 times. So we have to read it using a loop, and in every iteration of the loop, we have to put each number that we have to read from the user. We need to keep it in the array variable numbers. So we need one control variable for implement the loop. The control variable will be looping through 16 times. So we need a control variable, say for example $t0, $t0. So we need to initialize our control variable li t0 comma 0. Instead of doing that, you can also write, I think, add t0 comma $0 comma 0 comma. So that will also initialize the t0 to 0 anyway. This is our control variable for doing the loop, control variable or looping variable, whichever you like, loop variable. And we need one variable which will keep track how many odd numbers we have. So basically inside the loop, what we are going to do, we'll read one number from the user. In each iteration of the loop, we'll read one number of the from the user. We'll keep it in the array, and at the same time, we'll check whether the number is an odd number or even number. If it is an odd number, then we should keep a register that will be incremented by 1 for odd number, and there should be a separate register which will keep track of how many even numbers are there. So we need 2 more registers to keep track how many odd numbers and even numbers. So again, I'm explaining, the thing is that we are going to implement a loop here. The loop will be executed 16 times. In each iteration, loop will read a number from the user, and then it will store the number in the array, and then we should also, as well as after storing it, we should also check whether the number is an odd number or even number. If it is an odd number, a separate register should be kept, which will keep track of how many odd numbers we have, and a separate register should be kept, which will keep track of how many even numbers we have. So T0 is already being used for the loop variable, so we can use another loop variable dollar T1, which should also initialize to dollar T1 to 0. As we know that 0 is T0 is already initialized to 0, so T0 to 0 is also give you the same result. So this variable is not your loop variable. T1 is your um, loop is your register to keep track to keep track uh, total number of calls. So this is a register to keep track the to keeping track total number of odd. Then we need another register P2, which will keep track of total number of events. So this one will keep track of total number of events. Register to keeping track or register for keeping track. So register for keeping track total number of event. So we have to register T1 for keeping track how many odd numbers we have, T2 how many even numbers we have, and T0 is our loop variable. So that's done initialization, but two more things we need. We need to know the starting address of our array. Why is the array? So you can see this is you can think about this is a memory, just a fraction of memory. Now your array, definitely we have not stored any number in the array, but definitely as soon as you declare this array variable space 64, what the assembler will do, assembler will allocate 64 bytes, 64 bytes in the memory. So what the assembler say, for example, this is the beginning of your array, assembler will find, okay, this is the beginning of the array, because it requires 64 bytes. So from 12, this is the first element of the array, then second element of the array, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16. So up to this, from 12 up to this, whole memory location will be allocated for the array. But this is the beginning of your array. Remember, 0012 assembler has found that there are total 64 bytes being allocated by the assembler. All these 64 bytes from starting from 0012 up to 0075 will be allocated for the array whose name is numbers. So the numbers array variable will be stored here. This is the space that actually assembler found that this is a empty, and assembler will allocate that one. So that will be done when, as soon as you allocate your variable, as soon as you allocate your variable numbers, then the assembler will allocate the space starting from this. It will allocate total 64 bytes, and it will go up to 0075. So you can see that I have shown you the memory location all of 4 bytes long. Each of the memory, you can see that what length, that is 0012, 0013, 0014, and 0015. These are the 4 byte are in one memory location. This is another 4 byte in other memory location, like this. So this is the first address of the memory location where the memory is stored. So we can keep it this one. This is the first byte, but no data has been stored yet. This is just the starting address of our memory. So of the array. So what we are going to do, we'll get the starting address of the array in our S0 register. So how to get the starting address of the array, LA, which will give us the address, starting address of our array in S0 register, and the name of our array is numbers. So numbers is our name of the array. So S0 S0 is pointing to this memory location. So try to understand, S0 is pointing to this memory location. This is our starting address. Just assume this is our starting address. It's not necessarily always assembler will allocate the starting address of the of an array always in 0012 memory location. No, this is just an example that assembler will find out that these are the 16 bytes which are free. So operating system assembler will allocate or allocate this number of bytes for the array numbers, and this is the starting address. So S0 is now containing the starting address of numbers which is in S0, and we would like to also keep track of another variable which will also point to the starting address of the array. And in order to move, I'm just putting $S1 comma $S0 comma comma 0 $0. So S0 will be added with 0 and result will be stored in S1. So both S0 and S1 is basically containing the starting address of the array. So you can see, we can say that stores starting address of the array, and this is just copying the starting address of the array. As I told you in the class as well, there should be two register pointing to the beginning of the array. There should be two register pointing to the beginning of the array. So this is S0 is pointing here, both S0 and $S0. $S0 is pointing to the beginning of the array, as well as $S1 is also pointing to the beginning of the array. So both S0 and S1 pointing to the beginning of the array. But what we are going to do, we'll keep S0 as it is. It will always point 0012. But S1, in every iteration, it will go to a different memory location. So next time it will go here. Next iteration, then it will point to this one. Then it will point to this one. Then it will point to this one, then it will point to this one, like this. So S0 will remain as it is, but S1 is going to be changed in every iteration. So at the beginning, it should point to the beginning of the array, so which is this one, and then in every iteration, the S1 will go move to here, then 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 move to here, in this way up to the last element, up to this. Then again S1 will come back at the beginning of the array. So you can see that two of the registers now pointing to the same starting address of the array, but we'll continue this one. We'll continue this one with, later on. We'll continue S1. So we have declared total 5 register. You can see T0 is our loop variable, T1 for keeping track how many odd numbers we have, T2 for keeping track how many even numbers we have, S0 is pointing to the beginning of the array, S1 is also pointing to the beginning of the array. So now we are going to start our loop for reading integer number. Now this loop will be executed 16 times, so we can write branch greater or equal. So if the value of P0, whenever the value of P0 will be greater or equal to 16, because the P0 is starting from 0, so it should go up to 15 to make total 16 loop operation. In that case, whenever the T0 will be equal to 16 or it will be greater than 16, in that case we should come out from the loop. So you can again understand that our loop variable T0 is initialized to 0, and since it is initialized to 0, so it can go up to the number 6 up to the number 15 So 0 to 15 is total number of loop will be 16. So whenever the T0 will equal to 16 or it will be greater than 16, we should come out from the loop. So exit. So we should immediately create the label. Exit for loop. Um, so exit for loop. So if T0 is less than 16, we'll stay in the loop. If it is greater or equal to 60, then we'll come out from the loop. And when you are finishing the loop, I'm declaring end for loop another level. This level you will need, and this is the place where actually will initialize, it will increment the value of T0, will increment the value of S1, will change the value of, update the value of S1. So these things will do end for loop, but remember this end is does not mean that this is the end of this loop for reading. This is inside this loop. Exit for loop is the actually end of looping. This end task for loop, end task uh, for loop. Okay, so these are the last task for inside the for loop. That's why we are keeping this message. This is end task of for loop. Inside end task of the for loop, the last thing that we should do is jump to the beginning of the loop. Jump to the beginning of the loop. The beginning of the loop is this one, so we can copy that one. Jump to the beginning of the loop, and we'll do some other thing later on. Now, first thing first. If T0, which is our loop variable, is less than 16, we'll enter the loop, and inside the loop, the first thing we'll do, we'll read an integer number from the user. For reading an integer number from user from the keyboard, you know that is the interrupt number 5. So li $v0, comma 5. And syscall. So what this interrupt will do, it will read an integer number from the keyboard, and then it will store the number in P0. So we are just reading an integer number from the user, and then after reading that number, we must save it, move it to some other register. So what we can do, we can move it in, say, T3 register. We can move it to T3 register at $3, then $V0, dollar V0. So V0 is register is containing the first number reading from the keyboard, and then we are moving it T3. After moving it to T3, now we should now save the value from T3 to the array variable. Now, how to save? Store word. From where you want to save the word, from which register, P3 register that we have just saved, and then we are going to store it in the memory location that is pointed by S1. So S1, both S1, you can remember both S1 and S0, both are pointing to the first starting address of the array, but we'll always store the number in the memory location that is pointed by S1. So store word from T3, store it in the array which is pointed by S1. So storing the number into the array. Um, Now, next task is that we need to check whether our T3 is an odd number or even number. How to check? There are two ways, because before we go back to the beginning of the loop, if we want to go back to the beginning of the loop, then before doing that, we need to check whether the number which is stored in the array in T3 is the odd or even number. If it is the odd, then we'll increment our register for odd, which is T1, will be incremented by 1. And if it is even, then our register for T2 will be incremented by 1. So that's the thing that we are reading in the iteration, in each loop iteration. We are reading the number, storing the number in the into the array, and then we also check whether the number is odd or even. Now, in order to check the number whether it's the odd or even, there are two ways. One is that you can divide the number by 2, and if you get the remainder equal to 1, then it is an odd number, and remainder equal to 0 means an even number. But if you use the AND logical operator, you can remember that in case of AND logical operator, if your number is, say for example, number is a 16-bit number. So for example, you can represent 16-bit number like this. 8, say number 13. Your number is number 13. So this is 1, this is 1, this is 0, this is 1. So 13. So 1 plus this is 2 is 0. So 1 plus 4 is 5 plus 8 is 13. So if, for example, you have a number which is 13 in T3, if your number is 13, how do you know that it is a odd or even number? So what we can do, we can perform T3 AND operation between T3 and between a mask. So in case of mask, what we can do, we can check whether this value is either 0 or 1. The last bit is 0 or 1. So what we want to make the other bits equal to 0. So we are putting 0 there. This is our mask bit, mask bit, mask bit. We are making all other bits 0, except the bit that we are interested about. We'll make it 1. So this is our mask bit. Remember, this is our mask bit. This is our T3 value. Say, for example, T3 is containing value 13. Now we want to check whether this bit, is it a 0 or 1. Now, if we perform the AND operation between them, then definitely 0 and 0 is 0. 0 and this 0 and 0 is also 0. This 0 and 0 is also 0. So all will be 0. All will be 0 except the last bit. Last bit will contain 1. You can see the last bit will contain 1. So the whole register value will become 1. So if whole register value becomes 1, you can say that T3 is containing a odd value. If the whole register value is even, that is 0, then T3 is containing even value. So what we can do, we can perform an AND operation between T3 and that mask value is 1. As I showed you, the mask value should be 1. Mask value is 1. This is our 1. So I'm putting mask value 1. So there will be a AND operation between T3 and 1, and the result should be stored in, for example, T3, because already we have saved the value of T3 into the array. So if we lost that value, there's no problem. So $T3, store the result T3. Now we can check whether T3 value equal to 0. If it is 0, it's an even number. If it's a 1, it is an odd number. So what we can do, we can now check branch equal what is the value of T3. If it is 0, then we'll jump to even number. So we'll jump to even number because T3 is containing a even number. So we'll jump to even number, and inside that even number, what we'll do, we'll just increment our T2 register, which is keeping track of even. So we'll in here, we'll just increment the T2 by 1. So add I dollar T2 comma dollar T2 comma 1. So incrementing even register value. But if T3 is not equal to 0, if T3 is not equal to 0, that means if it is containing 1, that means it's an odd. If it is odd, we are not jumping to the even number. In that case, it will come here and we will increment the value of T1 by 1. So value of T1 by 1, add I, value of T1 will be incremented by 1. So you can see that if our T3, after performing the AND operation, T3 can contain either 0 or 1. Performing the AND operation between T3 and 1, the result will be stored in T3. Now, if T3 is containing 0, that means it is an even number. We'll jump to the even number. We'll add, we'll increment 1 to our T2 register, which is keeping track of how many even number you have. But if it is not even number, will not jump here. Rather, will come automatically here in the next statement, which is incrementing the odd number register. So it will increment the odd register value, or register value, and then if we don't do anything, it will again come to the even number and it will increment the T2 value also 1. So we don't want that. So what we'll do, we'll jump to the end task for loop. This is the place where we need to increment our loop variable. We need to change our value of S1. So we'll jump to end task for loop, So here, this is the place where actually we'll increment our loop variable. So first thing first, loop variable. So add I $p0 comma $p0 $p0 comma 1. So incrementing the loop variable. Incrementing the loop variable. So we are incrementing the loop variable, and after incrementing the loop variable, we need to update the S1. S1 should point to the next array element. In order to update S1, what you can do, you can use mul instruction, dollar T3, because T3, there is no use of T3 anymore, so we can just use T3 comma $p0, that's our loop variable, should be multiplied by 4. So whatever your index loop variable value should be multiplied by 4, result should be stored in P3. And then we need to update our add $s1, or update our s1 $s0 comma $p3. So your displacement will be stored in P3 after multiplying the index value by 4, that is loop variable by 4. The displacement will be stored in T3, so that T3 along with your starting address of the array, which is 0012, you will get new value of S1. So S1 will be now actually 0016. So S1 will be now 0016. It is because your 0012 is S0 value, displacement is 4. So 0012 plus 4, it will give you S1 equal to 16. So it will move the S1 register to the next. So what will happen in the next iteration, when you jump to the beginning of the loop for reading, T0 is now 1, which is less than 16. So since it is less than 16, so we'll not exit for loop. We'll read another number from the user. We'll save it in T3. Then from T3, we'll put it into the array, which in the array that is pointed by S1. You know that S1 is now pointing here, and then we'll check whether T3 is a odd number or even number by performing an AND operation between T3 and 1, and then T3 will either contain 0 or 1. So if T3 is containing 0, we'll jump to the even number, but if T3 is not containing 0, then we'll come automatically here. We'll increment the value of T1, which is basically incrementing the odd register value, and then we'll again jump to the end task for loop, where we'll increment the value of T0 by 1. will change the value of S1, or update the value of S1, so that S1 will now point to the next array element. So that will go like this, and then it will continue up to 16 times. So once this 16 iteration will be done, you already have reached 16 number from the user. The data is already stored in your array. This all array will contain the data, and now your T1 and T2 also containing how many even number you have in the array, how many odd number you have in the array. So after the exit loop, what we have to do, we have to print our output message 1. So in order printing for output message 1, v0 comma 4 LA $A0 comma output message 1. So output message 1 and syscall. So that is for printing output message 1, printing 1. And then after printing the output message 1, total number of odd number you have, total odd numbers in the array, we can print the value which is storing the odd register value, how many odd numbers we have, that is stored in T1. So we'll now print the value of T1. So in order printing any integer number, we need a interrupt number 1. So, and the number that we want to print, which is in T1, should be moved to A0. So add $A0 comma $T1. T1 is containing total number of odd 0, and then syscall. So this part is basically printing total number of odd. So we must put a hashtag. So this is printing the output message 1. This is printing total number of odd, not add, odd. And the same way we'll do it for output message 2. Output message 2 will print output message 2, that is even number, and we'll print the value of T2 because T2 is containing how many even number we have. So even number, that is done. So this part basically printing output message 1, and then how many odd numbers we have, which is stored in T1, we move it to A0, then we call the syscall. The same way we'll print the output message 2, and we'll move the T2 value to A0. T2 is containing the total number of even, and then once all done, now we can write li $B0 comma 10 comma 10, then syscall. So that is the end actually of our program. Let's see. Save the program. Okay, lab 8 problem 1. Save. Now we run, assemble. There is no problem. So we just anyway, it is not, that's the problem. Enter 16 integer number. We can start entering the 16 integer number. Say 10, 21, 23, 25, 35, 45, 65, then 60, um, then 75, then 80, 82, 84, then 89, 91, 93, 97. You can see that 16 integer number being entered. Total odd numbers in the array is 11. Total even numbers in the array is 5. You can see that we need to print a new line character. So what we can do, we can go to our here. We can print a after printing odd number, we can print a new line character. So we can declare a new line colon dot ASCII slash n. So what we can do in our output message one and printing the total number of odd, we can print the new line character. So li $v0 comma 4 la $a0 comma new line. So symbol it then run. Enter 16 integer number. You can enter 10, 11, 12, 13, 15, 17, 19, 21, 23, 25, 26, 28, 30, 34, 35, 38. So you can see the total odd numbers in there is 9 and total even number in there is 7. So if you add, you can check how many odd numbers are here, how many even numbers are here. So the output is given here. So we can go back to our the program. You can see this is our total program. I'm showing you a screen 25 lines at a time. 25 lines, and this is our second 25 lines. Yes, second 25 lines. Then this is our last code. So that's the end. We'll meet again for some other one, inshallah. Thank you for attending the class. So